One final thing that we've been talking about this week is the idea of solving for a particular variable. So I've got an equation here. It's an equation that has both an A and it has a B. And the question is, how do I get one of those variables alone? And it doesn't matter which one. So I could say, for example, that I want to get, let's say I want to get A alone, right? So when I'm done, I'm going to have an expression that says A equals something. Because I have a B here, the B is still going to be there, right? But A is going to be alone. So let's just try this. If I want to solve this for A, I'm going to get rid of this first. So I'm going to take away 2B from both sides. So this equation is going to become 3A equals, and I could write just 10 minus 2B. So if you look really closely, right, on both the left-hand side, I subtracted 2B, and on the right-hand side, I subtracted 2B, right? So this is what it looks like after taking away 2B from both of the sides. And now what I'm going to do is there's there's three terms, two terms on the right-hand side, one on the left. Every single term is going to get divided by 3, right? This is going to be divided by 3. This term is going to be divided by 3, and the last term is going to be divided by 3. So when I divide each of my terms by 3, I get A is equal to 10/3 minus, and I could just write this as 2/3 of B, right? Yeah, this is what this looks like if I solve for A. I now have A alone. Let's also solve this for B. So let's say that instead of getting A alone, I wanted to solve it for B. Same equation, but we're now going to get B alone. To do that, I'm going to take away 3A from both sides, right? So if I take away 3A from both sides, this is going to become 2B on the left equals 10 minus 3A. And now I'm going to go ahead and divide every single term by 2. So this is going to become B is equal to 5 minus 3/2 of A. So now I've solved for B. So you can see I can solve for B, I can solve for A. There we go. Solving for a particular variable. Let's look at one more example like this, and then we'll be done with this. Let's say that I have 3 times 2x plus 1 plus an x plus 3y equals 7. And I want to solve for x. I want to get x alone. Well, it's a little complicated because I've got these parentheses here. So one of the ideas that we've talked about recently is that I can rewrite chunks of this equation with equivalent things. So what I'm going to do is I'm going to rewrite this side, right? I'm going to rewrite this thing with parentheses so that I no longer have parentheses there. If I rewrite that chunk, it's going to become 6x plus 3 plus an additional x plus 3y equals 7. Now I can combine my two expressions with x, right? There are two terms with x. So I've got 7x plus another x, or I'm sorry, 6x plus another x will be 7x, right? There's 6 of them, and one more is 7x plus 3 plus 3y equals 7. I'll take away 3 from both sides, so 7x plus 3y is the number 4. Again, my job here is to get x alone. So now I'll take away 3y from both sides. So 7x is equal to 4 minus 3y. I subtracted 3y from both sides. And then finally, I'm going to divide everything by 7. When I divide 7x by 7, I get x. By the way, that's 7x. I divide 4 by 7, I get 4/7. I divide negative 3y by 7, I get negative 3/7 y. So this equation right here is the original one, right? But what have I done? I've solved for x. I now have a new equation in which x is by itself. All right, that's it for today. So please complete the practice problems I have assigned you, and I look forward to seeing you in class soon.